Chapter 7, Section 4, Process of Statistical Hypothesis Testing. Now, we are ready to learn statistical hypothesis testing. Next, let's see the concrete process of statistical hypothesis testing. The process of hypothesis testing consists of these steps. They contain some jargons, so if you have not seen these terms before, you may have no idea what they mean. And it may seem a roundabout process, but it is necessary to reach a conservative conclusion. In statistical analysis, we should be conservative to avoid giving out the wrong information. So, we should take these steps to conclude with as much certainty as possible. I will explain the jargons and each step in detail. First, let's see what null and alternative hypotheses are. Statistical hypothesis testing is often used to compare the proportions between groups and confirm the positive or negative relationship between variables. As noted in the previous slide, hypothesis is an assumption about population parameter. If the assumption is that there is no difference between groups, the hypothesis is called a null hypothesis, often denoted as H0. If the assumption is that there is a difference between groups, the hypothesis is called an alternative hypothesis, often denoted as H1. In general, a null hypothesis expresses the size relationship that contains an equal sign. So, it expresses that A equals B. A is larger than or equal to B, or A is smaller than or equal to B. On the other hand, an alternative hypothesis expresses a size relationship that does not contain an equal sign. So, an alternative hypothesis expresses a relationship that A is larger than B, or A is smaller than B. Let's go back to the example we saw in the previous videos. We want to confirm whether the left thumbnail is more attractive than the right one. It is a problem of comparing two groups. The null hypothesis assumes there's no difference, so it is the left and the right thumbnails get the same number of customers. The alternative hypothesis assumed there's a difference, so it is the left thumbnail gets more customers than the right one. Statistical hypothesis testing is done by determining whether we can reject a null hypothesis or not. So, in this case, we need to test whether we can reject a claim that the left thumbnail gets no more or no less customers than the right one. If we find that we cannot reject a null hypothesis, we should conclude that we cannot say the left thumbnail gets more customers than the right one. If we find that we can reject a null hypothesis, we can say that the left thumbnails gets more customers than the right one. If we can reject a null hypothesis, it means that the difference between groups occurs with a probability that we cannot say it is a product of chance. It should be noted that statistical hypothesis testing just tests whether we can reject a null hypothesis or not. Failing to reject a null hypothesis does not mean that we can prove that the null hypothesis is true. Thus, even if we cannot reject a null hypothesis, we cannot say there's no difference between the two images. We can only say that we cannot say that there's a difference between the two. That is, we can only say that even if we can see the difference between the two, it is highly possible that the difference is a product of chance. The second step of hypothesis testing is setting a significance level. So, what is a significance level? But before talking about the significance level, we need to understand errors we can make in hypothesis testing. We can commit two types of error in statistical hypothesis testing: type 1 error and type 2 error. Type 1 error refers to an error where we reject a null hypothesis when it is actually true. In other words, type 1 error means that we reject a true null hypothesis. Type 2 error refers to an error where we fail to reject a null hypothesis when it is actually false. In other words, type 2 error means that we accept the false null hypothesis. Significance level, often denoted as alpha, refers to the probability of committing type 1 error. A significance level is expressed by proportion or percentage. For instance, a significance level of 0.05 or 5% means that the probability of committing type 1 error is 5%. So, when we set the significance level to 0.05, our hypothesis testing should reject the null hypothesis only when the probability of committing type 1 error is lower than 5%. The third step of hypothesis testing is computing test statistic. So, what is test statistic? In statistical hypothesis testing, we test hypotheses based on probability. That is, we determine whether to accept or reject a null hypothesis based on probability. So, it is statistical. Specifically, in statistical hypothesis testing, we reject a null hypothesis if the probability of an event occurring is lower than the specified significance level. Well, let's consider an example of rolling a 6-sided die. Event A is getting an odd number. Event B is getting a pip greater than 4. Which event is more likely to occur? This problem is not so difficult because we can objectively calculate the probability of occurring. We can conclude that the event A's probability is higher than B's probability. But in a case where we do not have information about probability, the problem will be more complex. Let's consider another example. Suppose we collected data of body height from American and Japanese adult male persons. This is a sample data consisting of 100 Americans and 100 Japanese. In this sample data, the average body height of Americans is 180 and that of Japanese is 170. The data shows that, on average, Americans are taller than Japanese. Remember that a null hypothesis says that there is no difference between groups. So, in this case, we can set the null hypothesis that American male persons are not taller than Japanese male. And the alternative hypothesis can be that Americans are taller than Japanese. The data show that, on average, Americans are taller than Japanese by 10 centimeters, supporting the argument of the alternative hypothesis. So, in this case, the null hypothesis says Americans are not taller than Japanese, despite the fact that the data shows 10 centimeter difference between them. As noted in the previous slide, in statistical hypothesis testing, we reject a null hypothesis if an event's probability is lower than the pre-specified significance level. Here, the event can be defined as we can observe that Americans' average height is 10 centimeters taller than that of Japanese, even when, on average, Americans are not taller than Japanese. So, if we set the significance level to 5%, we can reject a null hypothesis if the probability of this event occurring is less than 5%. However, in this example, we have data of average height, but no information about probabilities. In such a case, we need to transform the data to probability distribution. This is where a test statistic comes in. Test statistic is a statistic that is used to test a hypothesis by transforming data into probability distribution. Depending on the type of testing, various test statistics are used. This is a list of popular test statistics, which will be covered in the following chapters. Using a test statistic, we can transform data into probability distribution. In the example of body height, the event is Americans' average height is 10 centimeters taller than Japanese, even when, on average, Americans are not taller than Japanese. So, in this example, using a test statistic, we obtain a probability distribution of the difference in average height when Americans are not taller than Japanese. This shaded area represents cases where we observe that, on average, Americans are 10 centimeters or more taller than Japanese. That is, this area is the probability of the focal event of this case. As noted above, if the probability of this event is lower than the significance level, we can reject a null hypothesis. Here, the significance level is 5%. So, if the probability of the shaded area is less than 5%, we can reject a null hypothesis. In statistics, the probability of the shaded area is called p-value. So, if the p-value is lower than the significance level, we can reject a null hypothesis. In this case, the significance level is 0.05. So, if the p-value is lower than 0.05, we can reject a null hypothesis. And accepting the alternative hypothesis, we can conclude that Americans are taller than Japanese. In the final step of statistical hypothesis testing, we calculate the p-value from test statistic. Then, compare the p-value with the significance level. If the p-value is lower than the significance level, we can reject a null hypothesis. By definition, p-value refers to the probability that the observed difference occurs where the null hypothesis is true. In other words, p-value represents the probability that the observed difference is a product of chance. The lower the probability that the difference is a product of chance, the more probable that we observe a real difference. So, the lower the p-value, the more likely the observed difference is a real one, not a product of chance. We can make decision in this step by either one-tailed test or two-tailed test. In the next video, I will explain one-tailed test and two-tailed test in detail.